Welcome. Have you ever wondered why it's so hard to get your hands on the data you need to make decisions? That it shouldn't have to involve many, many manual steps to wrangle the data, to figure out if it's right, and then to figure out who needs to have access to it and give it to them? More importantly, what can you do about this? In this session, over the next 45 minutes or so, we're going to share stories from the journey that the pharmaceutical company Takeda took in its journey to establish a data and analytics hub with the intent to improve the speed of decision-making and innovation. In essence, becoming an insights-driven organization. We'll break this session down into the opportunity and what some of the challenges have been, the solution that was envisioned and built, the journey undertaken, and the impacts and the benefits that have been achieved, and also a glimpse into what's next, a glimpse into what does the future hold. I'm joined by some great speakers here on stage. We'll take a moment to introduce ourselves.
Hi, I'm Raymond Darren with Takeda Pharmaceuticals, part of their Data Science Institute.
And I am Temi Adebambo, Senior Manager with Deloitte. I lead our cloud cyber risk practice for life sciences.
And I'm Raveen Sharma, also with Deloitte. I'm a leader in Deloitte's life sciences and healthcare practice. And I have about 20 years of experience in designing and delivering and implementing analytic solutions for the life sciences companies. These span from early stage research to clinical development to RWE to digital health. And I'm currently working with clients to apply emerging and innovative technologies to transform their processes. Deloitte is a very large global organization, and we organize ourselves into industry focus areas where our practitioners have very deep domain expertise. We also have a large group of dedicated experts in cloud engineering, cybersecurity, data sciences, and cloud operations. And this, combined with accelerators and products and best practices that we have in our solution areas, enables us to serve our clients well, to take them on cloud journeys that are transformative and sustainable.
Thank you. For those not familiar with Takeda, just a brief background. Takeda Pharmaceuticals is the largest Japanese pharmaceutical company and one of the top 15 worldwide. It has about 30,000 employees and operations in over 70 countries around the world. At the beginning, Chobei Takeda, its founder, started working as an apprentice in the medicines district in Osaka, Japan. As part of his experience, he decided in 1781 to go out on his own and establish his own company. As the company grew and prospered in the 19th century, they began to import Western medicine. They actually pioneered it within Japan. And they started manufacturing within Japan as well. Moving into the 20th century, as the company continued to grow and prosper, they began to work outside of Japan and move into international companies, international operations around the world. Moving into this century, as a lot of the pharmaceutical companies experienced mergers and acquisition, Takeda also set out to acquire some companies. It acquired Millennium Pharmaceutical to bolster its oncology division, and then later acquired Nycomed to introduce itself into many countries around the world, 70 countries as it moved on forward. And continuing its growth, it later on launched, I should say, a global product, Entyvio, one of its larger products at the time. Moving into more recent history, as part of trying to continue the growth and bolster the future, areas where it has some expertise, namely oncology, GI, CNS, and vaccines. It formed partnerships to allow for additional work to be outsourced as needed. It continued the acquisition, acquiring Ariad, again, trying to bolster its oncology division, and set up Shonan Research Center to look for external-facing work and collaboration as we went forward. At the same time, they formed the Data Science Institute, again, as of which I'm part of. Challenges and opportunities. According to PhRMA, which is the Pharmaceutical Research and Manufacturers of America, the average time to take a drug from discovery to market is about 10 years. The average price to take a drug to market is estimated to be about $2.5 billion. According to the FDA, 95% of drugs that enter clinical trials never make it to market. Over the past years, there's been a steady decline of drugs that have hit blockbuster status. Those are drugs that make about $1 billion in revenue or more. These are not great odds for a pharmaceutical company, not even for Vegas terms. But this isn't the only thing that's pushing the pressures. It's not just pharmaceutical companies. Even those outside, government agencies that are trying to deal with epidemics need quick solutions. Payers that are trying to pay for the drugs and the medication, et cetera, are looking for lower costs. Patients are looking for better options for themselves. Doctors are looking for better ways to treat the patients and make sure that the treatments they're putting on actually work for the patients that they have. There are increasing demands for change, and the case for change is not new, but it is increasing and moving forward. So how do we deal with this? What's the cost? What's the pace at which we can go about implementing new solutions, improvements, innovations? Could it be big data? Maybe. It's disrupting a lot of different industries and potentially could disrupt life sciences as well. This is big data, not just gathering all the data together, but the analysis, the analytics, the machine learning, deep learning, the algorithms, artificial intelligence that goes along with part of this. This is the what if space. This is the what if we can take all the genetics of a person and add in their history, add in their medical records, add in their heritage. What if we knew where they lived and what kind of environmental exposures they had? What if we knew the habits that they had? What kind of stresses do they see on a day-to-day basis? What if we could get all this information for all patients, all people around the world? What can we possibly do with this? Can we identify correlations? Can we identify causal relations? Can we be able to identify places where we can prevent disease or even cure it? Biology is very hard, but this is the promise of the future, and hopefully we can get there. What about execution? We're hoping to learn a lot from the big data and the technologies and the advances that we've seen. But in terms of execution, we also look at the processes, the workflows that we have around the company. A lot of the focus over the past years has been on specific functions. A lot of the efficiencies have been squeezed out of these functions, and now we're looking at more of interdependencies and even integration of data across different functions and different workflows. The hope and desire is to be able to work through these and be able to predict as opposed to be reactive to some of the needs, making sure that the clinical trials continue as planned, supplies get there, as the enrollments go up. If the portfolio needs to be adjusted, the resources can be seamlessly adapted and moved on. So where do we start? If we're hoping to reach the objectives that are on the left-hand side, how do we pull together our different data? How do we organize it? How do we be able to make the most use out of this? We look at two axes that we try to organize our data around. Organizing the data to be able to learn and organizing the data to be able to execute on these things. As we keep peeling back the onions, obviously there are different layers. We try to organize them to keep it in the scientific, operational, processes of research, development, so on and so forth. There are many strategies and tactics that can be used to this, and Raveen will cover some of these as he talks later on. But one of the things that we decided to do is keep it very simple. Keep the patient at the middle, make sure that we're looking at drugs and diseases, those relationships between those two, and keep the ingestion process very simple and make sure that the cataloging and the categorization of these data is easy and seamlessly fluid across the different boundaries. Before we can tackle some of the bigger problems, there's always the little more immediate and more urgent issues that come along. These are not specific to Takeda. Over my years of experience, whenever we've taken a look at different functions and their challenges, it's usually the same type of activities. It is access to information, whether it's the amount of access, the timeliness access, the ability to be able to collaborate across different boundaries, looking for a single source of truth, somewhere where we know what we see is the final data, and also for efficiencies and workflows across the different functions. And now Raveen will walk us through one of the solution models and some of the practices that we put into place.
Thank you, Raymond. That provides a great framing and understanding of the opportunity and some of the challenges that have been experienced. We thought through the solution vision, the vision for the solution, and also how we wanted to go about achieving it. We also early on established that this is going to be a business-focused initiative. It's not going to be driven by IT or technology or systems choices. So with that in mind, we thought through what we needed to do. So the first thing was setting the scope. This is intended to be R&D wide. So all the way from early stage research and target identification to clinical development, and then to data around products that are already on the market. The intent was also to address siloed data across functions, across geographies, and across the entire product lifecycle. Access to trusted data. This is something that was very key and very critical. So there's data that's disjointed, there's data that is unknown, and there's disparate data in the organization. That had to be handled, taken care of, and brought together. Collaboration, both internal and external collaboration, and that really begins with having users have access to the same data. So the users that we're speaking about range from C-suite level executives looking at portfolio information, all the way down to business end users looking at their programs, and then also to the contract research organizations, the CROs who supply information and execute trials for the pharmaceutical company. All of this had to move very fast. Okay? So you saw the opportunity. That opportunity has to get captured. And so what that necessitated was a fast, agile approach in terms of project methodology, but also a simplified architecture that was flexible and open and modular. What we also did very early on is identified things that could slow us down. Where are there issues? And so we took out our bulldozer and started moving through those things and trying to address those issues. And really the path to trusted data lies through data governance. So in the organization, we felt there needed to be a bit of a rejuvenation or a reset of the data governance capabilities and functions to enable the path to trusted data. We also identified very specialized cloud skills that had to get acquired or borrowed or fulfilled. And then for support of future use cases, validation in the form of compliance to CFR 21, Part 11 regulations had to be addressed as well. And validation in the cloud is something that is in pretty early days for the life sciences industry as a whole, and Takeda is taking a leadership role in that. All that said, the data has to be secure. In some cases, there's very highly confidential information being ingested into the data hub, being managed, and then being sourced from the data hub for various applications. So the data had to be very secure. So here's the snapshot of the end state, if you will. So the end state of the vision. And starting with the left-hand side, right-hand side. In orange, what you see is a flavor for the different functions within R&D. So we said this is R&D wide, and we weren't kidding. This really is any data that is produced in R&D can be ingested into the system. They range from clinical and research operations to medical affairs, to regulatory, to portfolio management, and so on, and supply chain, and even procurement. So these structured and unstructured data sources from systems and sources within Takeda and also external to Takeda are ingested into the data hub through various mechanisms, either APIs, batch data transfers, or even manual uploads. And these are brought into a single point of storage in S3, and then from there, the data is progressed and migrated up into the appropriate environment for the particular use case at hand. Some of that goes into an HDFS Hadoop-based data lake for the appropriate use case. Some of that makes it into a more relational data store. In either case, or in every case, the data is cataloged and the lineage is tracked so that users can, first of all, find the data and then understand what happened to the data along the way between the time it was sourced and between the time you actually look at that data element in an output. In this environment, tools were provisioned for data scientists to perform ad hoc analyses and queries. In this environment as well, we provisioned for certain use cases some innovative pieces from Amazon. So later on, I'll speak about a use case for applying Amazon Lex, and then also the TensorFlow machine language package from AWS. Moving along, on the data consumption layer, that's the primary interface to the business. And really, the business interacts with visual outputs. So those come in the form of dashboards and analytics portals, which can be quite sophisticated. And you'll get a glimpse of those in a few minutes. Because this has become a very trusted source of information that is brought in from many different sources and integrated and cleaned and tracked, there's a lot of downstream consuming systems that are also recipients of this data hub. Another area where we piloted some technology was in the area of conversational interfaces in the form of chatbots and voice assistants. And that's actually gaining a lot of interest and a lot of ground in this area that we'll touch upon. So now the journey. How do we get there? So because we had to move very quickly and very fast, we couldn't take the classic Big Bang approach where you had to gather all the requirements ahead of time to then design a data model, which then gets transformed into a monolithic data warehouse, and then maybe in about a year's time, the end users can actually get some value and benefit out of that. That was just a non-starter. The business wouldn't engage in this approach. So what we did is we partnered very closely with the business. Remember, again, this is a business-led or business-driven initiative. And really tried to understand what are the high-priority business questions that are being asked. What is the data and what are the analytics that are needed to support getting answers to those high-value business questions? So we listed those out. And then, because we don't know everything ahead of time, we had to adopt an open and flexible architecture to take us along this journey. Based on that, we determined a roadmap of the high-priority use cases. And this is a roadmap that then gets refreshed and validated with the business every quarter. So in essence, the tagline we're using here, our methodology, is we adopt a use case-driven approach to implement an open architecture with a progressive roadmap. So drilling down a little bit from that high-level approach, we codified 6 guiding principles that we use to communicate our approach and our strategy to the business so they understood what we were doing and what we were up to, and why we were always at their door interacting and asking questions. So the first is it's business-driven. As I mentioned before, this is not an IT project. This is a business-driven initiative to deliver business results as fast as possible. It had to be purposeful, and that means a couple of things. It had to stay true to mission. So there's always a chance that as use cases come up, you kind of get caught in the fray and you kind of start straying from your mission, and you find out a little ways down the road that you've spent an inordinate or disproportional amount of resources solving that use case, which doesn't have leverageable artifacts for other places. So we'll speak about that. Had to be fast. I keep saying fast because people don't have patience. They want the answers, they need to make decisions, and they want the data to support their decisions. Trusted. Basically, the data has to be right. There's no room for error here. Innovative. So the architecture had to be open and flexible enough to allow for the trying of new things and trying of new techniques and new methods. So that's where the innovation aspect comes in. And then underlying all of this, the platform had to be secure, which is a key tenet of this platform that Temi will talk to a little later. So business-driven. So this illustration is an output of engagement with our business stakeholders. So we interviewed early on about 20 or 30 business leaders within Takeda and their teams to identify what are their high priority issues, what are their gaps, what do they need, what keeps them up at night. And we started generating this view of that output. So each circle or each bubble represents a use case, you can say. On the y-axis, you have urgency. Is it something it's okay, it's kind of moderate, or is it something that has table-pounding urgency? I need this now, otherwise I can't make a decision that's based on data and too much risk is introduced into the process. So urgency was a key dimension. Along the x-axis is a composite score for difficulty. And it's a composite score because it takes into account the measures of, is it technically challenging to solve for this use case? Is the data available, or is the data very hard to get for this use case? And then also a measure of the culture, or the amount of change management that's required to implement that use case. So combining those all together gives us a measure of difficulty. The size of the bubble is the potential impact or benefit to Takeda. Okay. And then the coloring, which we had to obfuscate a little bit, really refers to the class or type of use case. So if you gather enough data points, they tend to organize themselves a little bit into classes. And so you can see the oranges tend to be a similar type of class. And the use case categories were really centered around what you see over to the side. Operational analytics and data, scientific analytics and data, cataloging capability. So that one struck us as interesting. And we drilled a little into that. And really what it was all about is you just said, well, where's my data? What data do I have available for me? And then inventorying aspects, such as how many entities are within this group or within this folder? How many studies do I have? How many studies am I conducting? And then there were a slew of others. And so this was really used to then figure out where to prioritize our efforts. This was done in conjunction with the business. So they saw very clearly where we were spending efforts, what was going to come out of the roadmap first, and then they understood the logic and rationale behind that roadmap. And again, that roadmap gets refreshed on a periodic basis with the business so that they are vested partners in this journey. So purposeful. So this graphic is an illustration of a certain type of use case. And this is a use case for data collection that spans the product portfolio. So you've got product portfolio is segregated by the phase of development that the asset is in, and then the therapeutic area that the asset is in. And the initial aspect of this was to make sure that we weren't spending too much effort on non-leverageable assets. And so what we did is we drove to reduce as much variation as possible by standardizing and also leveraging enterprise data assets. And this allowed us to create a minimal set of data analysis, data ingestion, and data processing templates such that most of the variety or most of the variance in the use cases could be accommodated. And so the mantra here for this class of use case was really to build area and then quickly scale to build volume in terms of data and use cases served. So there's a way of balancing the needs of the business with the realities that you've got a certain set of resources you can apply to a problem. We had to go fast. So we used a hybrid agile approach, and that really forced and caused us to have close engagement and interaction with business stakeholders. There were many work streams run in parallel, and where it made sense, we would do 2-week sprints to generate deliverables and incremental deliverables. And then every 6 to 8 weeks, we did an integrated release of all the available assets out to the business. A lot of the benefit of moving quickly is you discover issues very early on, so you can correct them and adjust for them. So the visibility of surfacing bad data was actually a huge benefit, so that the organization can see, okay, this data is not accurate, it's not timely, it's not complete, it's not good. So something has to be done about it. It has to be addressed. So that really caused the case for everybody's favorite topic, which is data governance. You want to invite a whole bunch of people to a meeting and not have anybody show, you title that data governance. And that's basically what happens. So from an end user perspective, this is how they view, or this is how they see the solution. So they start to understand that the sources of data coming in to their environment are streamlined and governed and organized. Within the data hub, there's integration happening in data management and data processing, and then the data analytics happen. And then that gets sent to a set of visual outputs or dashboards. And really what this has helped them to do is to apply these techniques for data-driven decision-making. So the automation, the standardization, and the data transparency happens behind the scenes, and that gives them confidence that they're applying the correct data to their business problem. This is just a quick sample of some of the business interfaces, and they span the entire spectrum of R&D operations use cases. And in some cases, the analytic portals are quite sophisticated, and they've achieved a lot of success in certain areas. So all of that is only as good as the data that underpins or underlies that. And so in this case, we had to rejuvenate, or we had to refresh the data governance methodologies and data governance processes at Takeda. So we established specific domain working groups. And for example, what that means is there might be a working group that is centered around all the data elements required to define an asset. So, that includes what studies are conducted, what is the definition of a study, what are the attributes that have to be maintained about that particular study, and then what are some business rules that have to be governed, such as what determines what phase a particular asset or a particular study is in. And so these working groups define the ownership and accountability of those data elements. So if there is an issue, if you're an end user and you see an issue, or an executive and you see an issue on an output or a dashboard or analytic portal, or if Lex gives you an answer that you think is wrong, then you can go to somebody. There's a process of accountability to figure out what's happening with that data. And in many cases, data is corrected within the source system through a process. And so this is a case where the more visibility there is on the data, the more transparency there is on the data, the better the data is going to become through this process. So that's the way, or that's the path to trusted data for decision making. Innovative. So this is a fun topic. So the entire data platform, Data Hub platform, is in AWS. And AWS comes out with tons of services that we learn about in conferences like this. And so what it really means is this environment is innovation ready. You can try new things very quickly, very readily. And one of the areas where we tried things out was in the area of conversational interfaces. So we all have some experience with Alexa at home. So that's an interesting interface where the machine tries to accommodate our lexicon, our requests. When you think about interfaces at work, where you're typing in information, basically you're conforming to the way that the computer, the way that the system wants to receive information. And so we thought this would be a good way to try this out in an enterprise setting. So we picked a use case where you really want to get a straight answer. how much does this cost? Or how much do I have left on purchase order XYZ? And those are the types of use cases that initially lend themselves well to this type of chatbot. Use cases which you don't apply to a chatbot, obviously, are ones where you're looking for trends in data or you're looking for patterns, because that's not what we tried initially. And so what we saw is that there was an adoption of this in a piloted setting, and now we're looking at many set of use cases across the R&D spectrum. So again, because that service is available in Amazon, we're able to try it out. And in a matter of 3 weeks, we were able to vet whether this thing was going to be good and useful, or whether we should just put it off to the side. Another area that we're spending a lot of focused attention on is the application of machine learning, or AI, or cognitive. So in this case, we're leveraging the TensorFlow package in AWS. And it's really pointed at that big circle that you saw Raymond describe, where we're trying to understand the diseases better. We're trying to understand the disease pathways, and we're trying to understand the outcomes of patients along those disease pathways. So that's a way that innovation is being brought into the environment. Next, I'll turn it over to Temi to speak to us about security.
Thank you. So as you guys have heard, there's a lot of pieces around the business to get the solution to a point where they can get the data they want out of it. But how do we secure it? How do we make sure that the data lake platform remains secure, vigilant, and resilient? And I think of it as a path, just the way Ravina just spoke. We have to start with assessing the risk on the platform and understanding what is the baseline security requirements for the platform. So if it's FDA, EPR, what are the different regulations that it needs to comply with? And this also has to evolve because now we have GDPR as another regulation coming into the space. So we have to understand what are the risks that are facing the platform, baseline some security requirements, and create a roadmap and evolve that as it goes along. The next area is to establish the controls and the responsibilities for the different areas of controls. In order to do that, we definitely need to also take advantage of the technologies that can help us reduce risk and identify those upfront. A lot of these activities need to be done ahead of time and in an iterative process in order for us to really get to a point where we can design the security capabilities. We need to definitely understand the risk vectors and understand the controls we are planning to put in place to address them, and then consider what security capabilities we have. Logically, in order to work in the cloud in a fashion that is automated, we would want to create architectural design patterns so that it's going to be repeatable. We want to be able to have security architecture that is really driven by code as much as possible, and then move on to a point where we're able to build, test, and deploy the security capabilities, which is where everyone's usually excited to get to. Let's build it, let's secure it, and let's deploy it. But it takes a long path to kind of get to that point where we can adequately do that. And then finally, create a support model that can sustain it, that can maintain it, and have security operations in line with it to make sure those processes that are designed are maintained. Because there's definitely different instances where you've designed something and it works well, but over time, the maintenance and support lets it down. So that's one area we don't want to lose out on. So what security capabilities are needed for cyber risk management on a data lake? The diagram you guys are looking at right there kind of depicts how all these areas are connected together and how we would try to tackle each one to address security on a data lake. Let's start with the first one, identity and context. Data lake environment is one that potentially opens itself up, being a collaborative environment, to internal and potentially external users. Managing the access from the enterprise, extending it to the cloud, and making sure that we understand who's accessing what data, especially given the high level of the classification of the data that is within the platform. And that brings us to the second one, which is the data security. Most organizations already have data classification schemes and different layers and requirements for different areas of of data classification. We need to take that into account and understand the level of data we have in the platform and what we need to do to secure it. Going to the third one around governance, risk, and compliance, it is very important to have governance around the whole platform. The controls we talked about, we need to have responsibilities mapped to it. We need to have ownership. We need to have tools potentially that help us enforce some of the policies and processes that are put in place. The fourth would be around application security. Think of secure software development lifecycle. Applications and different dashboards are built on the data lake platform. We need to be able to securely build these applications, migrate them from their dev to the prod in an agile fashion, as been talked about, having different dev environment, test environment, and a production environment. Factoring in secure and dynamic code analysis to make sure that vulnerabilities within the applications are adequately addressed, and not just on the AWS layer, but also at the application layer itself. And definitely vigilance. A lot of customers out there complain about lack of vigilance in the cloud. A lot of people are able to, within the organizations, spin up servers, EC2 instances, S3 buckets, and they have no vigilance within it. The enterprise typically has some vigilance for the on-premise. We need to get that connected. We want to get that single pane of glass. You don't want to monitor just the cloud and the data lake itself without monitoring the enterprise. We need to take a look at all the data together and be able to get intelligence from what we're seeing in the cloud, what vectors, attack vectors are hidden in the cloud and which ones are hidden in the enterprise, and be able to correlate that and have true vigilance over the entire security platform. Moving on to resilience. Resilience is important. While no one wants to have a situation where the system goes down for whatever reason, it is important to have disaster recovery, to have business continuity plans, to factor in how the business will stay connected in the case of an event, whether it's security-driven event, operational event, or even something triggered by AWS region going down, for example. How does that affect the business? And how can we architect around such unplanned events? And finally, the network and infrastructure. Having good network security is obviously a good barrier. Back in the day, security was rather simple. You got to secure your perimeter. Now we're talking of the cloud, and your perimeter is not just your enterprise walls. It extends to the cloud and all the different areas that the data lake platform is built around. So these are the areas that we had to tackle from looking at security. These are all the different pieces. And as I said, some of this is still actually being improved upon as we go, because we started with the assessment. And now we're in the point where we're building and operating the platform. So I'm going to dive into a few of these areas. One of those that are very important is the data security on the platform. It's important to have encryption at all the layers for data security. And that means take a look at the application layer. Make sure the applications that are being developed, they have encryption built in, because the data lake hosts upon the platform a bunch of applications and reporting tools. They need to have encryption at that level. The transport layer, the data moving back and forth, need to deploy SSL, TLS technology, make sure that we have security at the transport layer, and when data is in transit, it's been adequately secure. The EBS volumes across the data lake need to have security, encryption set up on all of those. And then the object layer, the S3 bucket, as well as the database, need to have encryption. So data lake is built in such a way that at each layer, there's some encryption to make sure that it is built to a very high data security standard and is able to host the type of data that we're looking to have it housed. Next area that I want to touch on is Vigilant, which I mentioned. And this is done in a little bit of phases. The first aspect is to make sure that the login sources are all turned on, because if you're not getting the log information and the audit data on the platform, then you're not actually able to make intelligent information around the security of the platform. So the first thing is to turn all the log sources on. AWS has a ton of different log sources that the application can have sending into the cloud security platform that's supposed to ingest all of that. And then having that second layer shown below where you have the CloudWatch alarms turned on. So you have baselines established of how things should operate. And when they cross that baseline, the alarms are set up. You have integration into a SIEM so that you are able to correlate all the data that you've seen and be able to get information from all the security logs. And you have a cloud security platform. There are a few third vendor parties that play in this space that gives you cloud security on the AWS platform itself. You're able to take all that data and you're able to get intelligent monitoring information from them. The next layer to doing that would be then to automate it. So if someone was to spin up or put up a unsecure S3 bucket or create a security group that is not secure, the next layer is to be able to have security Lambda functions that are written to address that incident so that we have the automation not just in the deployment, but also automation in the correction and alerts for situations that are potentially risky to the environment. So these are some of the considerations and the flow of maturity around the security in terms of monitoring, turning all the logs on, getting them ingested into a smart solution that can actually give you intelligence, and then correcting it in an automated fashion. The third area, the resilience. Resilience is it's important. It's one of those that people think of last because everyone wants it to work. They don't want to worry about what happens when it breaks down as much. But AWS does a ton of work around the high availability solutions, and there's continuous improvements in that area. So having a strategy that is able to accommodate the multi-region, multi-AZ solutions from AWS is very important, and building the applications on the platform to support those services. Infrastructure as a code, that's very popular around when you're working with AWS, having the governance in such a way that you're able to take advantage of infrastructure as a code, having design templates so that people are not creating things from the scratch, but they're actually creating from design templates that have integrated controls in them, and having an architecture that they can follow and built in such a way that if something was to fail, it does so into a defined known state. We don't have a failure into an unknown state as much as possible. And finally, just the operations, because if you log everything and you have a SIEM, but we don't actually have a good security monitoring center that's able to address incidents and is able to manage the platform, then we still leave some exposures there. So the last piece of resilience is able to respond and having the people assigned to this. So those are the three areas we want to emphasize when we're looking at security for the platform. Is it secure? Are we vigilant, and can we see into the environment and know what's happening? And if anything ever happens, are we resilient enough that we'll come back to a known state and we can, provide value to the business without impacting it for a very long time? So, talking of impact, I'm going to move over to Ramin to give us some of the insights as to how all of these solutions have actually impacted the business.
Thank you. We're getting a little long on time, and I'm very uncomfortably hot up here, so I'm going to go through this quickly. Impact to Takeda. What is the biggest impact that we had? The biggest impact that we had at Takeda was we've started a different dialogue. We've started a conversation within Takeda where data is more than just what resides in a system here or in a system there. We've started to look at the data across boundaries and to be able to visualize it so that we can make use of this data and make decisions on them. The discovery of some of these analytics, the discovery of sources of data and being able to quickly ramp up on some of these things has changed the conversation from the quality of data and looking at and discussing, is this really the latest thing? Is this the newest report, et cetera, to really looking at what the data is trying to tell us and where we want to go and what's the decisions that we want to make moving into the future. Lessons learned. Change is hard in any organization, and especially when you're trying to be a bit more disruptive, when you're trying to do things quickly, when you're trying to change the way people work. Make sure you're planning for that. Make sure that you have this as part of your actual deployment and energy and resources put behind it. Don't underestimate it. It's not just a one-time thing, it's a continuous thing. You need to make sure that you are constantly addressing this as you move forward and try to improve on what you've put in. Speed rules. Whether you're talking about efficiency, whether you're trying to prove a concept, whether you're just trying to show that it can be done in a much different timeline than what you're used to. This is what you need to focus on, at least what we found to be very effective in trying to change the hearts and minds of folks. When they see something that can be up and running in weeks, when they're used to seeing things in months, that's a big difference. That changes the way they look and react to what you can do and how you can do it. Partnerships are the new norm. It's no longer internal. We can't do it alone. This is just the new normal. Everybody needs to bring in the expertise and the activities from other organizations, make sure the collaboration and partnerships continue. Externalization is the way that things are moving forward. Cloud platforms, again, talking about speed, going back to speed rules. When we're trying to put something up and running, internal platforms and processes are not able to keep up with it. We're looking at new ways to do these. Anything that we can ramp up quickly on an external platform, software as a service, these types of things will help us in the future, and they're very effective in moving forward. The future, there is obviously a short term and a long term. The long-term vision is to be able to address the issues with our patients, to be able to come up with cures and drugs to deal with the illnesses that we have. Short term, where we want to go with this is the next steps in terms of our evolution. Qualify the platform. We're working with AWS and our partner Deloitte as well to put together a plan to be able to qualify this so that we can quickly ramp up validated applications on it. Self-service, this is another focus we have. As we look at the ability for folks to access data, we want them to be able to analyze it and be able to make use of it themselves, rather than have to go through 3 layers of permissions and different folks to be able to aggregate the data or propose it in a different way. Obviously, the AWS services, again, comes into play where we can make use of it and accelerate any development we will. And expansion of data types. We've focused a lot on operational data to date, but we are moving into scientific data. We are putting together platforms and making use of different data that we have either internally, we're accessing through our CRO partners, or even subscription of data that we have in order to be able to analyze the diseases and hopefully come up with better insights and new platforms for the future. And with that, we thank you and open it up to questions.